Now, sometimes we get to deal with expression that looks more than just a trinomial. They may give us a trinomial that come with brackets, come with some weird expressions that look difficult to work with, but many of them can be dealt with using a simple substitution. And very often, those brackets you're going to see will be the same. Similar to the one in example number 2a. I see the same bracket here and there. 2x plus 1. Instead of expanding your perfect square and then simplify the expressions, group the like terms and factor it from there, what I would do is to replace it with b for bracket. I got a bracket here and there, and they are the same. 2x plus 1. Let me consider this bracket as b for now. And here I have a trinomial that I can factor. Can we factor this? Would it be 2b, 3b, or 1b, 6b? 1b, 6b? Okay. If it is 1b and 6b, what would be the other two numbers here and there? 5 and 2, 2 and 5? You probably only have one option in this case. And once again, I will not do this. I will not use 2 and 5 this way, because putting a 2 here will now give us a GCF from the first bracket. But once again, the question here does not come with a GCF. And that's why we shouldn't end up with a GCF from the first bracket. I wouldn't use 2 and 5. I would use 5 and 2. So now the 5b from the inside, the 12b from the outside would add up to 17b in the middle. So I need both of them to be a plus. Once we have factored the trinomial, I can now go back to the question and make the proper substitution back to the question. It was 2x plus 1. 2x plus 1. We use b for 2x plus 1. We make that substitution earlier, and we want to put this substitution back to the question. When I have 2x plus 1, the 2x plus 1 plus 2 will give us 2x plus 3. And then the 6 times 2x plus 1, that will give us 12x plus 6 plus another 5. That will give us 12x plus 11. So this is how I will factor this trinomial. Now some of you will probably try to expand the perfect square and then group the like terms together, come up with a trinomial, and factor your trinomial from there.
Can you do it that way?
You can do it this way for example 2a, when the questions are still relatively simple. But if I get to work with a fourth power, you probably don't want to expand it that way. You don't want to expand your 3a minus 2 by 3a minus 2 and 3a minus 2 and 3a minus 2. Like, unless you want to practice your algebra. and try to expand it that way. But once you've expanded, you still wouldn't be able to factor this because you have just made this whole thing more complicated. When you want to factor your expressions, you want to make it simple. You want to make it easy to deal with.
Sorry, where did the minus 11 come from, or the plus 11 come from?
Okay, going back to example 2a, right?
Yeah, the 11.
6 times the bracket will give us 12x plus 6.
Yeah.
And you add 5 to it. Any other questions before we move on to the next one? 2b. Okay, the next one. If this is not a trinomial, what could it be? Does it look like a square minus another square? Yeah, it looks like it. It looks like we have a perfect square, but for now, it doesn't give us a square. Let me make it into a square. Now I have a square. What about the second part? Is it a square? Yeah. 4 is a square. This is definitely a square. Let me consider this as the square of this whole thing. And now, with a perfect square minus a perfect square, it works more like difference of square. And I will have a minus b times a plus b. If this is a square minus b square, we will end up with a square minus b square. But of course, the a and b for now looks more complicated than just a and b. We will see this whole thing here and there. And then we will see this whole thing here and there. At least we are able to factor these expressions, and hopefully it will turn into something that is easier to handle. From this one, 3a minus 2. As we put it here and there, I will end up with 3, let me expand it at the same time, 9a squared minus 12a plus 4. This is what I will get when I square the 3a minus 2. As I expand this, 3a minus 2 times 3a minus 2. When you want to expand this, you can do it by FOIL. Or if you remember your special quadratics, you can expand your special quadratics into a trinomial in one single step. So that's what we will get. 9a squared minus 12a plus 4. For the second part, this is 14a plus 2. As I multiply the 2 by the 7a plus 1, we end up with 14a plus 2. 14a plus 2, 14a plus 2. We will end up with 9a squared minus 26a plus 2. Be very careful with the sign when you are adding or subtracting your terms. We are having this whole thing minus the second part here. You are going to distribute your minus into it. And that's how you end up with the 3 terms at the end. 9a squared will still be 9a squared. Negative 12a minus 14a will give us negative 26a. And finally, plus 4 minus the positive 2, it turns into 4 minus 2, or positive 2 at the end. That's the first bracket. For the second bracket, things are a little bit more straightforward, as you are simply adding the terms together, and this is what it will look like.